students, welcome to Vidya Myriad. This video is made for class 9 on chapter number 10 circles, and today we are going to do exercise 10.6, which is an optional exercise from Ncert. Let's begin with question number 1. Prove that the line of centers of two intersecting circles subtends equal angles at the 2 points of intersections. Now if you see at the diagram, the 2 points where they are intersecting is P and Q, which means that we need to prove that angle OPO dash is equal to angle OQO dash. So we can prove this by making the two triangles congruent. So in triangle POO dash and triangle QOO dash, we know that OP and OQ, they are equal, they are the radius of the circle. O dash P and O dash Q is also equal, they are the radius of the circle, and there is a common in between OO dash. So by SSS property, the triangles are congruent, and when the triangles are congruent, we can easily say that angle OPO dash is equal to angle OQO dash by CPCT. Question number 2. Two chords AB and CD of length 5 cm and 11 cm respectively of a circle are parallel to each other and are on opposite sides of its centers. If the distance between AB and CD is 6, find the radius of the circle. Now what is given to us? AB is given 5 cm, CD is given 11, and MN is also given as 6. Now OM and ON are perpendicular, so we know that perpendiculars drawn from the center of the circle bisects the chord, which means AM will be equal to MB and CN will be equal to ND. So it means that MB will be half of AB and ND will be half of CD. So MB becomes 5 by 2 and your CD becomes 11 by 2. Let us mark it and see what we can get. Now in triangle OBM, we have some information. Total MN is your 6. So I have taken ON as X, so MO will be 6 minus X. So in triangle OMB, and using Pythagoras theorem, we can say that OB square is equal to OM square plus MB square. Put the values 6 minus X the whole square plus 5 upon 2 the whole square. So you will get OB square as 36 minus 12x plus x square plus 25 upon 4. Let it be equation number 1. Let's consider triangle OND. In this case, OD square will be equal to ON square plus ND square. ON is x square and ND is 11 upon 2 the whole square. So we get x square is equal to x square plus 121 upon 4, which is OD square. Now OB square, OB and OD, they both are equal as they are the radius of the circle. So OB square and OD square can be taken as same. So we can equate both the equations, and from there we can find the value of x, which comes out to be 1 after solving. Now we will just put this value of x in one of the equations. Let us put it in equation number 2. OD square is equal to x square plus 121 upon 4. Just put 1 in place of x. You get OD as root of 125 upon 4, which is 5 root 5 upon 2, which is your required answer. Question number 3. The length of two parallel chords of a circle are 6 cm and 8 cm. If the smaller chord is at a distance of 4 cm from the center, what is the distance of the other chord from the center? Which means OM we are given to us 4 cm. We need to find ON. Now AB is 6 cm, which means MB will be 3. CD is given us as 8 cm, which means ND will be 4. So based on this, let us see what happens in the two triangles. In triangle OMB, OB square will be equal to OM square plus MB square, and on this OB comes out to be 5 centimeters. Now OB will be equal to OD since they are the radius of the circle. So using this information, we can find out ON in triangle OND. OD square will be equal to ON square plus ND square. OD we know 5, ON we have to find out, and ND is 4. So ON comes out to be 3. So distance of the other chord from the center is 3 centimeters. Question number 4. Let the vertex of an angle ABC be located outside a circle and let the sides of the angle intersect equal chords AD and CE with the circle. Prove that angle ABC is equal to half the difference of the angles subtended by the chords AC and DE at the center. So it means that we are given that the chords are equal, that is AD is equal to CE. We need to prove that angle ABC is equal to half of angle DOE minus angle AOC. Now what we are going to do is focus on the triangle BAE. In this, what we will do is we will use the exterior angle property. Your exterior angle property is sum of two interior opposite angles. So what is exterior angle over here? Angle DAE is your exterior angle, which is equal to angle ABC plus angle AEC, which is equation number 1. Now if you look at DE is a common line segment which subtends angle DOE at the center and angle DAE in the remaining part of the circle, which means that angle DAE will be half of angle DOE. Similarly, on the other hand side, if we take AC as the common segment, in that case angle AEC is equal to half of angle AOC. So let it be equation number 2 and 3. From all the equations we get half of angle DOE is equal to angle ABC plus half of angle AOC. So just take AOC on the other hand side. You will get ABC is equal to half of angle DOE minus AOC, which is proved and it was required. Question number 5. Prove that the circle drawn with any side of a rhombus as diameter passes through the point of intersection of its diagonals. Now here we are given there is a rhombus ABCD whose diagonals intersect at O. So a circle, we need to prove a circle with AB as a diameter passes through O, and angle AOB comes out to be 90 degrees. Why? We know that diagonals of a rhombus bisect each other at 90 degree. And in your right angle triangle AQB, if we take it as, then AB is your hypotenuse and angle AOB forms the semicircle, and angles in the semicircles becomes 90 degree. So this is angle AOB, not Q. So I just correct it here. So in triangle AOB, if you say AB is the right angle triangle, AB is the hypotenuse, so angle AOB forms the 90 degree, and thus we have proved that the point of intersection of its diagonals will be 90 degree. ABCD is a parallelogram. A circle through A, B and C intersects CD, produced if necessary at E. Prove that AE is equal to AD. Now ABCE is a cyclic quadrilateral, and we know that in a cyclic quadrilateral opposite angles are 180 degree, which means that if I take angle B and E, that is angle AEC plus angle ABC will be equal to 180 degrees using the cyclic quadrilateral property. And if we look at E point, your E lies on DC, and if I take AE as transversal, there are two angles formed, so I can use linear pair property, which means angle AEC plus angle AED will be equal to 180 degree because of the linear pair. So from there both the equations we can come to know that angle AED is equal to angle CBA. But ABCD we know that it's in a parallelogram opposite angles are equal. So what happened is we can say that angle ADE is equal to angle CBA, and from both the equation it is quite clear that angle AED is equal to angle DEE, and when the base angles are equal we can say their adjacent or opposite sides are also equal, so we can say that AD is equal to AE. Next, AC and BD are chords of a circle which bisects each other. Prove that AC and BD are diameters and ABCD is a rectangle. So let us prove this by using the given information. We will make the two triangles congruent first. Triangle AOB and triangle COD, the opposite triangles. Now AO and OC are equal because O is the midpoint, and BO and DO is also equal because O is the midpoint, and we are told that AC and BD, these are the chords of a circle which are bisecting each other. Now angle AOB will be equal to angle COD, which is vertically opposite angle. So by SAS criteria, both the triangles are congruent, and when they are congruent, we can say that AB is equal to CD by CPCT. So that means arc AB will be equal to arc CD also, and arc AD will be equal to arc BC. If I add both the things, it becomes arc AB plus arc AD and arc CD plus arc BC, which means arc BAD will be equal to arc BCD, which means that BD is common, which is dividing the circle into two equal parts, and thus we can say BD is a diameter. Similarly, AC is also a diameter. Now just we have proved that AOB and COD is congruent, so we can also say that angle OAB is equal to angle OCD. They are forming alternate angles. It means that AB is parallel to CD, and thus we can say that ABCD is a parallelogram. And we know that in the opposite angles of a parallelogram are equal. So we can say that angle DAB is equal to angle DCB. But DAB plus DCB, if I say they are equal to 180 degrees, because in sum of the opposite angles of a quadrilateral is 180 degrees. But these angles are equal. So what we can say, each angle is 90 degree. And when each angle is 90 degree, it holds the property of a rectangle. We can say that ABCD is a rectangle formed. Question number 8. Bisectors of angle A, B and C of a triangle ABC intersects its circumcircle at D, E and F respectively. Prove that the angles of the triangle DEF are 90 degree minus half A, 90 degree minus half B and 90 degrees minus half C. Now let us see over here. First let us consider that we know angles in the same segment are equal. So if we take angle FDA, this will be equal to angle FCA, considering FA as a segment which is common, which is the red lines if you see. Now if you see the blue lines, angle EDA is equal to angle EBA. These are the angles, they are formed in a same segment. So if we add both the equations, we get angle FDA plus angle EDA is equal to FCA plus EBA. So what does it mean? It means angle FDE is equal to angle FCA plus angle EBA. Now what is FCA? Half of BCA. What is EBA? Half of CBA. So now let us take the triangle property, triangle ABC, and using angle sum property, we know A plus B plus C, that will be equal to 180 degrees. Let us take A on the other hand side and keep B and C on my same side, which you will see that it is reflecting the same thing. Angle BCA plus angle CBA is equal to 180 minus angle BAC. But if you look above, we know that half of BCA plus half of CBA is FDE. So let us just substitute it. Let us divide it into half. So it becomes half of angle BCA plus half of angle CBA is equal to half of 180 minus angle BAC. Now what is half of BCA plus CBA? That is angle FDE. So FDE will be equal to half of 180 minus BAC, that is 90 minus BAC divided by 2. Similarly, we can say that angle FED will be equal to 90 minus angle CBA divided by 2, and angle EFD will be equal to 90 minus angle BCA divided by 2, and thus we have proved what is required. Question number 9. Two congruent circles intersect each other at points A and B. Through A, any line segment PAQ is drawn so that P and Q lie on the two circles. Prove that BP is equal to BQ. Now here we have given the figure. We will join AB and we will see that APB and AQB are the two triangles formed. And here we can say that angle APB is equal to angle AQB, because AB we can take it as a common segment. So angles on the common segment, they are equal. So we can say that in triangle BPQ, APB is equal to AQB, that is are the base angles. So it becomes an isosceles triangle. So that means their sides will be equal. That means BQ is equal to BP. Question number 10. In any triangle ABC, if the angle bisector of angle A and perpendicular bisector of BC intersect, prove that they intersect on the circle of a triangle ABC. Now we need to prove that angle BDE is equal to angle CDE, which is equal to 90 degrees. So here we will join BE and CE. Now we know that AE is the bisector of angle BAC. That means that angle BAE will be equal to angle CAE. So what does it mean? Their arcs will be equal, and when arcs are equal, it means the chord is also equal, which means chord BE is equal to chord AC. Now let us take both the triangles. Triangle BDE and triangle CDE, the below triangles. We know DE is common, we know BD is equal to CD, it's given to us, and we know BE is equal to CE, we have just seen above. So by SSS criteria, triangles are congruent. So what happens when the triangles are congruent? We can say that angle BDE is equal to angle CDE, but they are on a straight line, they are forming linear pair. That means their sum will be equal to 180 degrees, but because they are equal, we can say that angle formed is 90 degrees. So we can say DE is the right bisector of BC. That's all for this optional exercise. Though it is not compulsory, but still I thought to explain you this. It's not very difficult. You must try solving it. Thank you very much, children, for watching the video till the end. Very soon I am going to come with the next video. Till then, see you children. Goodbye. Take care.